see if I can switch back to the right screen. All right, now I'm having that same problem. Just a second. You're probably going to see a little bit more than you need to see, but that's okay.
Yeah, I see you. Yeah.
All right. I think we're good now, right?
Yeah.
Okay. Okay. Sorry about that, everybody. So once we get our cluster good to go, then we go ahead and install SQL Server. And to install SQL Server, it's going to be, again, Enterprise Edition only. That we're installing. And once you install SQL, again, as a standalone instance, you can do this with clustering, but it's a little bit outside the scope of our introduction talk here. It is possible to use failover clusters. But in this case, we're going to be doing a standalone instance. And when you install SQL Server, you have to go into Configuration Manager, or you can do it from PowerShell, and enable always-on availability groups. And I'll show you this in the demo here in just a second. It's a little checkbox that's unchecked by default, that until you check that box and restart your instance, you won't be able to join it to an availability group. So it's a nice little gotcha. I forget to do it almost every time I set this up, so make sure that you remember to do that. And so without further ado, let's take a look at the demo, and let's set up an availability group from scratch. All right. Bear with me while I get switched over to that. Oops. Hey, Sharon, can you mute?
Yep.
All right. I think you should see my screen now. So the first thing we're going to do is look at Configuration Manager. And so it's really small, I know. I'll zoom in here in just a second. I'm going to open up the SQL Server service. And there's now a new tab at the top called Always On High Availability. And right here is this checkbox I was talking about where it says Enable Always On Availability Groups. By default, that's going to be unchecked. And if you're not in a Windows Server cluster, it won't even be available to you. It'll be grayed out and disabled. But if you are part of a cluster, as you see here, I'm part of demo cluster, then you can go ahead and check this box, and then you'll have to restart your instance for that setting to take effect. And that essentially tells SQL Server to coordinate with the cluster, the Windows cluster, to keep track of the state of the cluster and who's up and who's down and that kind of thing. So I've already done that. By the way, my scenario is similar to the one that I showed you in the diagram. I have a domain controller and 3 other servers. The first 2 servers are going to be local, and then the 3rd server will be in a remote data center. And that's what we're going to use to create our availability group from. So I've already gone ahead and enabled availability groups. And if we take a look at our cluster as well, just to see and make sure that our cluster is good, all of our nodes are up. They're all happy. So we're going to be using Always On Rep 1, 2, and 3. Those are my 3 servers. Now right now you notice all 3 of my servers, they have a vote. And that's part of the quorum process. And quorum is essentially a voting process. And it's twofold. The first part of the voting process determines whether or not the cluster is up and running or whether it shuts down. And if you lose a majority vote, the cluster will shut down. If you have a majority vote, the cluster will stay running. In addition to that, the nodes vote and they pick a primary node to host the clustering services as well. And so in this case, if I go back to my main screen here, I see that Replica 3 is currently running as my my host server of the cluster. So essentially, it's just determining who's hosting the cluster and is the cluster up or down. It also prevents split brain to where our services can start running. In this case, we'd have 2 primary replicas, and that would be really bad if we had 2 primary replicas, because now maybe I'm having transactions run on one server and another set of transactions run on another. They become out of sync, and then how do you recover from that? How do you bring them back in sync and get to a consistent state again? And that's what quorum is for. It prevents us from getting into that scenario. And so like I mentioned during the slide deck, Microsoft does make some recommendations on the votes that you should get. And so in my scenario where I have 2 local instances and I have a 3rd instance that's remote and for like DR purposes, they recommend taking a vote away from the DR replica. So essentially the whole idea of this is to automatically allow for high availability. So nodes 1 and 2 are my 2 high availability nodes. Let them go ahead and fail over automatically between each other. And then anytime I'd have to fail over to that 3rd node, which is the remote one in my DR site, that should all be manual, because if it's bad enough to be a disaster recovery scenario, then I can go ahead and take manual steps to make that happen. Because the last thing you really want to do is to have your availability group fail over to your DR site when it doesn't need to, and now all your traffic is happening across the WAN and it slows things down. You don't want to have that scenario. So they recommend taking a node vote away from our 3rd cluster. And that's essentially what this PowerShell script does. It's going to talk to the cluster, find our 3rd node. Node weight is whether or not it has a vote. So it sets the node weight to 0, essentially taking away that vote. And then it just enumerates our cluster and tells us who has votes and who doesn't. So I'll just go ahead and run this now. And we'll see that it went ahead and left the votes on replicas 1 and 2 and took away the vote on replica 3. Now if I go back to my failover cluster manager and go back to nodes, you'll see that it immediately reflects that. So you can already see that it took the vote away from replica 3 for us. And again, this is all about stability. It's all about having the voting work appropriately. And really, do we really want a replica that's across a WAN that may be kind of an intermittent connection to have a vote and to have to be, be involved in this process? We only really want it there if we're going to manually fail over to it. We don't really want it to be involved in that whole voting or automatic failover process. So again, it's kind of just going back to the purpose of why we have that node there and whether it gets a vote or not. So that takes care of our cluster itself. So this is now in Microsoft's kind of recommended scenario. So I'll go ahead and close this out. I'll go into our SQL Server Management Studio, and you'll see that I have a set of databases here. I have AdventureWorks 2012 and I had AdventureWorks DW 2012. So I have some application and its data warehouse, and they're related to one another, and so I'm going to go ahead and protect these in one availability group. So to do that, you see the highlighted node here called Always On High Availability. I'm going to right-click that and do a new availability group wizard. And this wizard's really nice. It'll walk us through the entire process. So the first thing I'll do is I'll hit Next and just give my availability group a name. So I'm going to call it Demo AG. And once I've named it, it's going to ask me what databases should be involved in this. And so what's really cool about the screen is it already has checked whether or not they meet the prerequisites. In this case, both of them do. And what are the prerequisites? Well, the prerequisites are they should be in full recovery mode because I need a transaction log for replication to work. And they've had a full backup taken at some point, so that initialized our log chain. If I don't have an initialized log chain, or if I don't have full recovery mode, there's no way that I can use the transaction log to send across that replication data to the other nodes and keep them in sync. It's a lot like with transaction log shipping or database mirroring. It needs to be, you need to have that T-log, and that's essentially what that's checking. So since they both meet prerequisites, I can go ahead and check both boxes and move forward. And now on this screen, it's going to ask me to choose my replicas. And I'll zoom in here in just a second. Let's go ahead and add a replica 2. So it's going to have me connect to replica 2. And we'll add replica 3 and connect to that. And let me choose my options and then zoom in and talk about them. So let's do that real quick. All right. So on the screen, we've got some tabs across the top. We start in replicas, and we'll work our way through the rest here in just a moment. And in replicas, we have our primary, and that's who we started from. So I was connected to replica 1, so that becomes my primary replica. I can have up to 2 automatic failover partners, and so those are the 2 replicas that will fail over and fail back for patching or for if there's a hardware failure. They'll do that automatically, and so that's what these 2 replicas are for. Now you'll notice or if you notice, when I checked the box for automatic failover, it also checked the box for synchronous commit. And that's Microsoft saying, well, if you're going to allow automatic failover, you probably don't want to have a scenario where it could fail over automatically and lose data. So we want you to have synchronous commit mode. And what synchronous commit mode is it's saying when somebody does, let's say, an update statement on the primary replica, that update statement has to happen on the primary replica. The statement has to complete. It has to commit on the primary replica. The transaction has to be sent across over to the second, any other synchronous commit replicas. So in this case, we'll say to replica 2. So that it has to be sent across to replica 2. It has to be hardened into the transaction log of replica 2. And then that has to be acknowledged back to replica 1. Once that happens, then the transaction completes on replica 1. And so if I'm a user and I'm running an update statement from Management Studio, and I hit run, I hit F5, that's the end. That's the process that it goes through. It tries to commit it locally. If that succeeds, it will then send the transaction across, harden it to the log of the secondary, acknowledge that back, and then I will receive the statement saying, hey, that finished. Here's how many rows it affected. If it doesn't get hardened into the log of the secondaries, it will fail at the primary and roll back the transaction. Now, I said this kind of in a very specific way, too. I said harden into the log. So it doesn't actually have to be fully committed on the secondary replica. It just has to be written into the transaction log, because that way when we do a failover event, we're going to replay the transactions in the log back into the database, at which point then it will be solidified as a committed transaction. So we don't actually have to commit the transaction fully. It just has to be written into the log, and then we can acknowledge that back. Conversely, in asynchronous commit mode, which is what our third replica is going to be, all we have to do is queue up that transaction to be sent across to that replica, and that allows us to complete. So we don't actually have to send that transaction. It doesn't have to be written into the log. It just has to be kind of queued up locally to be sent out, and then that's enough for it to be successful on the primary. Additionally, we also have our readable secondary column here, and you notice that I selected yes for all of these. Readable secondary is saying, is this in a restoring mode or is this in a read-only mode? And also, if it's in a read-only mode, who's allowed to connect? So I said yes, and yes is kind of the legacy option here. Yes means anybody can connect to my secondary replicas who are going to be in a read-only mode, regardless of whether they specify that application intent equals read-only keyword in their connection string. And this is really there for if you're an older version of the native client trying to connect up to the SQL server. It will still allow you to connect without having that keyword available to you. There's two other modes, or two other options here. One is no, and no means no. I hope you all know that. No means no. It means essentially you're not going to be in a read-only mode. You'll be in that restoring mode. You won't be able to connect. You won't be able to run select statements. It basically makes it like with database mirroring, where that second replica is just there for bad things to happen. And then finally, read-only or read intent only is the same as yes, with one little caveat. It says we'll make the secondary replica a readable replica, but we'll only allow you to connect to it if you give us application intent equals read-only in your keyword. And so it's kind of locking you into, you have to tell me you're going to be read-only, or else I'm not going to allow you to connect at all. So those are your options here on the replica screen. In this case, I'm selecting automatic failover between my two local replicas because I want them to be the high availability replicas that fail over between each other. And I'm not selecting synchronous commit on my DR site because that WAN connection, it may be up, it may be down, it might be slow, it might have latency. Do I really want my end users to have to wait the round trip for that to commit, or sorry, to harden into the log of my DR site and then round trip back to me and say, yep, I did it? That could be a serious amount of latency added on top of an already busy server. So I don't recommend setting synchronous commit for a disaster recovery site. The other tabs we have are endpoints, and endpoints are basically creating what used to be database mirroring endpoints. If anybody recognizes the port number 5022, that's a database mirroring endpoint port, and these are what we'll use to do replication. And so if you don't create your endpoints, then your replicas will immediately become out of sync, and that's not a good thing. So you'll notice by default that it creates these for us. Those were already populated for me. But if you're doing it manually, just make sure that you do create these. The third tab is backup preference, and this is kind of a nice option here. It allows us to say where we want automatic backups to run from. And when I say automatic backups, essentially I'm talking maintenance plans. So the idea being I would create a maintenance plan on all 3 of my replicas that looks to these settings and will only run if it is the preferred replica. And there are behind the scenes, there's some system functions and DMVs that you can query to determine whether or not you're kind of allowed to run a backup or not. And so if you were running just from T-SQL, backup database, that kind of a command manually, it's going to let you do it. Just assuming that if you're running a transaction log backup or a full backup, that you're doing it from somewhere you're allowed to run it from. But it's not going to check this. It's only whatever you're using to backup has to know to look at these settings. So if you're using a third-party tool, or if you're using whatever method it is, it needs to know to look at these settings. But it is a nice option that Microsoft lets you tell SQL Server, yeah, I really only want to have my secondary replicas running backups, or I really only want to ever run on my primary, or exclude this replica, or weight this one replica over the other. Those are all options that we have on this screen that are available to us. And then finally, we have our listener name. And so I'll set up our listener name, and I'll zoom in a little bit so we can read it better. I'll name it the same as our availability group. So the first name I gave it was kind of the internal name to SQL for that availability group. So if I were going to use refer to this in T-SQL, that's the name I would use. In this case, this is where I'm creating a DNS name or a host name. We'll call it demo AG, the same thing as our availability group. I'll put in my IP address information, so I'll give it an IP address on each subnet. So that's on our DR site. This one will be on our local network. And essentially, whatever server is hosting this listener name will bring up whatever IP address it can based off of what subnet it's on. So if I'm in my local data center, the only address I would be able to bring up would be the 10.100.100 address. If I'm in the DR site, the 10.200.200 address is the only one I'm able to bring up. And when a failover occurs and I grab the listener name, as say replica 2 or replica 3 becomes the primary replica and it brings up this listener name, part of what it does is it updates DNS and says, hey DNS, I'm hosting this listener name demo AG on address 10.200.200.200. So that way it keeps their environment up to date as well by updating DNS. So this is one half of kind of that secret sauce of of offloading our workload, right? Is having this listener name available to us, because that's what we're going to connect to in probably 99% of our scenarios. We can still connect directly to any one of these instances if we want to, but if we want our application to automatically fail over, then we're going to make sure that we have the listener name following the primary replica. So let me go ahead and zoom out here. The next thing it's going to do is want to synchronize our data. And so in this case, we have 3 options: full, join only, or skip. I don't really recommend doing a skip. I highly recommend doing one of these 2 options. So full is for if we don't have the database on the secondary replicas and we need to create it and restore the data, then we'll basically be taking full backups as well as tail log backups, restoring those onto the other replicas. And it uses a share somewhere to do that. So not following best practices, I have a share on my domain controller. Don't do that in production, but this is a demo. And that share is where it's going to save those backups to and then restore them from. Join only would be used if we already have our database on all of our servers and it's already they're already basically in sync, and there's not activity happening that would create one of them, make one of them out of sync. So that's basically where I did the work, automatically, or sorry, manually, and full is where SQL is doing the work for me. So if I hit next, it's going to run through a checklist of just testing out that share and making sure that it can create a database, back it up, restore it on the other replicas. It's really thorough, and it's really quite nice what all of this walks through. So it went ahead and did that and confirmed that yes, everything is good. It can go ahead and do that. We'll hit next one more time, and we get the typical, here's your summary screen. And instead of hitting finish, I'm going to hit script here, and I'm going to script it out to a new window. Because like any good DBA, I want to know what it's doing. And also, I may have change control, or I may have some kind of a source control system I need to store this in, or any number of things where I need to know what it's doing and maybe have it keeping track of that. And so that script allows us to do that. So I'm going to go ahead and get rid of that one. I have another one kind of standing by here that we're going to run it, and then while it's running, I'm going to talk through it. And so the first thing you need to do to run it is to switch into SQL CMD mode, and that's because it's going to be switching back and forth between servers. And so all these kind of gray highlighted areas where you see :connect is where it's switching servers and doing the same thing on different servers. So I'll hit F5, I'll let that run in the background, and let's just kind of talk through this quickly. So the first thing it's going to do is it's going to look for a login called SQL Service, because that's what's running my SQL server is SQL Diablo /SQL Service. And it's going to create that login on all of our servers. And the reason being is that's what we're going to use to go ahead and allow our replication to happen. So we'll create the login on all of our servers, and we'll also grant permissions to our endpoint to that login here in just a minute. So we'll create that login. We'll then create our endpoint, like I was mentioning. So we'll create an HADR endpoint. There's that 5022 port number. It'll be for data mirroring, so that should look familiar. And it will automatically be encrypted for you, essentially, is what this is doing. And we'll then go ahead and alter that and start it. And finally, it will grant connect on our endpoint to our SQL service. And so that's why we created that login ahead of time, was to grant connect to it. And that basically creates the endpoint for us to replicate on and gives us permission to do so. Scrolling down here a bit, the next thing it's going to do, there is an extended event session that ships out of the box with SQL 2012 and higher called always_on_health. And that's how our availability group knows from the SQL Server perspective what's going on whether it's up and running, whether it's good to go, whether there's problems and it needs to fail over. This always-on health extended event session is kind of the SQL side of that. And then that checkbox at the beginning that I talked about, where it's enable always-on high availability, that's from the server and Windows cluster perspective. And then the two talk to each other to figure out then should a failover event occur, who becomes primary, that kind of thing. So they coordinate with one another. So what we do is we go ahead and just alter that, start it up, and then tell it to start every time that our instance starts as well. And then now we get to what's really interesting. We get to the create availability group statement here. So we'll create our demo AG availability group. We're going to prefer to run our backups on our secondary, so that was that kind of third tab we looked at briefly. It'll be for our two application databases, so it'll be for AdventureWorks and AdventureWorks DW. And then now we have Replica on, and we have a clause for each of our replicas. So Replica 1, and we tell it how to get to it. So we give it the endpoint URL, and this is how we get to that, that database mirroring endpoint. We then tell it what failover mode it will be. It's automatic failover. So Replicas 1 and Replica 2 are both automatic failover. Because of that, they're also synchronous commit for the availability mode. And you'll notice that Replica 3 is manual failover because you can only have 2. And it's asynchronous commit because it's distant, it's not nearby. And then our backup priority, this is that waiting, and they're all 50 because I didn't really want to set that or do anything with that. And now we have secondary role, allow connections equal all. And this is kind of a weird way of saying what that last drop-down list was in our replica screen, where we had yes, no, and read only. So this is essentially saying when I am the secondary replica, allow connections from anyone. I could also have none, and that would be when I'm in the secondary role, don't be readable and don't allow connections from anywhere. And I could also have this be read only, which would say go ahead and make it a read-only replica, but it has the connection has to have that application intent equals read-only specified for me to allow them to connect. So once we've created the availability group, we now create our listener name. And our listener name will be called Demo AG, and here's the 2 IP addresses and subnet masks for that, and the port number that goes with it. And then finally, we join our second and third replicas to our availability group. So we alter availability group Demo AG, and we join it on our second and third replicas. And that brings them into the availability group. Then what we do is we go ahead and synchronize our databases. So we're going to back up our AdventureWorks database and restore that onto our secondary replicas, and do the same thing with the log as well. And then we'll just wait for the for communication to occur. This is kind of just, this should already be happening, but it's just kind of waiting and making sure that our joins that happened earlier, where we said join the availability group, have finished. Once they have, and the replicas are part of the AG, then we go ahead and alter our database, set HADR availability group equals Demo AG. What that does, this statement again is running on our secondary replicas. So this will run on replica 2 and replica 3. And it's telling those replicas to join that database into the availability group and begin synchronizing it with the availability group. Once we do that for our AdventureWorks 2012 database on both of our servers, both of our secondary replicas, we'll go ahead and do that with our DW database as well. So essentially the exact same steps. We'll synchronize it, join it, and make sure it's good to go. And our query finished successfully. So at this point I can close this window. And before we go ahead and take a look at this, one more thing. I have a set of scripts here that are the read-only routes that I mentioned earlier. And these read-only routes are kind of split into 2 parts. The first part says when I am in the secondary role, so when replica 1 is the secondary role, what does it do with a read-only connection? And it's going to keep that connection. So if I'm the secondary role and I receive a connection inbound that's asking to be a read-only connection, I want to keep that. And that kind of makes sense, and it's a little weird at the same time. You potentially could offload again, and so if replica 1 was a read-only secondary replica, it could route you to another server if you wanted it to. In most cases, I don't think you'd want to do that, so I just have it go to itself. And then for the second half, this one makes more sense. So when replica 1 is the primary replica, where do we offload our read-only connections to? So replica 1, when it's the primary, will send you to replica 2 first. If that's not available, you'll go to replica 3. And then for replica 2, you'll go back to replica 1 because, again, we're in the same data center, so we want to keep them there if we can. And then we'll finish off with replica 3. And then replica 3 will go to 1 and then 2. And so these read-only routes are what offloads our read-only connections automatically for us. So now let me go ahead and disconnect from our one replica. Let me connect to Demo AG. That's our availability group. We see our databases here. We also see, I'll zoom in just a second. I know this is kind of small. We also see our availability group listed out here now in Object Explorer. And so here is all the objects in our availability group. So we've got the availability group itself, and I'm currently connected to the primary replica. That's why it says primary next to it. And then you see each replica, so replica 1, 2, and 3. Replica 1 is currently the primary. You see the 2 databases that are part of the availability group, and the little play symbol means that they're replicating and that they're healthy. And then finally we see our listener name. This is our Demo AG listener name. I can also right-click on the name of my availability group and go to Show Dashboard. And I get a really nice health dashboard now with some great information. I'm going to zoom in on this a little bit to make it easier to read. Essentially, we have an overall health, and that's green checkmark healthy, so that's a good thing. Our failover mode is automatic, so right now if something bad happened to replica 1, it would automatically fail over just fine. We see details for each of our replicas and how they're set up, and we see details for each database on each replica. Now, the one thing I don't like about this dashboard is down here where it says data loss. And immediately, as a DBA and somebody managing this, I would freak out, and I would go, oh no, there's data loss. Bad things have happened. Why is it green check marks when there's data loss? It doesn't necessarily mean that there has been data loss. It means if a transaction happens and we fail over, there's the potential to lose some data because we're in an asynchronous commit mode on Replica 3, and that's why it says synchronizing, is because it's asynchronous, versus synchronized for our synchronous commit replicas. So again, it doesn't mean there has been data loss. It means there's the potential to have data loss if you fail over to that replica and it's not yet finished synchronizing the transactions. So it's a little bit alarming when you first look at it, but if you understand what it means, you'll be okay with it. So I know we're kind of over on time. I do want to give one more piece of our demo here. If my SSMS cooperates. That's interesting. All right, we'll come back to that. I have an application that essentially lets me connect to a database and run a query a whole bunch of times, just one after the other. So the connection string I'm going to use here is just to connect to demo AG to AdventureWorks, and we're going to run a query that has the important part here being it has an update statement. All right. So I'll go ahead and hit connect, and the first thing we see is that we got connected to Replica 1. Right? So that's what we would expect. Whoops, wrong button. We're on Replica 1, and that's our read-write replica, because I didn't give it an application intent, so I went to the primary. I'll start executing, and we'll see the results coming back here, and that's exactly what I would expect, right? So if I go ahead and add on application, oops, if I can spell, intent equals read-only, and I hit connect again, now you'll notice that we're on Replica 2. And so that followed our read-only routing and offloaded me to Replica 2. And if I try to run that same update statement, I would expect this to fail, right? And it does. So down here at the bottom we have an error message. It says that it failed to update the database because the database is read-only. Well, that's what I would expect on a read-only replica. But what's cool is I can take the update statement out of here, and all I have are select statements now, and I can run this. And now I'm running read-only activity off of a secondary replica, and it's succeeding. So that's pretty cool. All right, so let's go ahead and switch back to the slides and just wrap things up. So what I recommend is that you do a little bit of homework before you even are ready to go to availability groups. And really, it's not so much you that's doing the homework, it's your application developers. So if you have in-house applications that talk to SQL Server, have them split out the connection string. So have them have one connection string that's for your inserts, updates, deletes, and have another connection string that's just for your read-only activity. And the reason being is, those could point to the exact same place and have the exact same connection string and just go to one server and one database right now while they do the development to split that out in code, because that will take them a while. Then when you're ready to go to availability groups, all you have to do is switch your connection strings to A, to point to your listener name, and B, on your read-only connection to put that application intent equals read-only. And now that first connection string, that read-write connection string, will stay on your primary replica. The second connection string that's for read-only activity will now be offloaded to your secondary replica where it should go. And now you've kind of split out your workload, and you'll start seeing some performance benefits from that. Additionally, use the multi-subnet failover equals true keyword in your connection string as well if you're in a situation like I just demoed where we have replicas on different subnets or in different data centers. What it essentially does is it will look to all of your replicas and see who is up and responding, and then it will go ahead and reconnect much faster than if it just tried to connect one at a time. It essentially just speeds up the way that your reconnection happens after a failover event has occurred. Also, don't forget to add retry logic to your application. What I didn't demo here just due to time was what happens to that application when there's a failover event. And essentially what happens is that the application will fail during the failover because the primary replica is no longer in a a usable state, and our secondary replica has not yet come up as primary, so it's not really even in a usable state. So we'll see some failures happen kind of intermittently during that process. But then once the failover completes and the new primary replica is fully online and available, we will begin running our queries on that server without having to disconnect and reconnect. Really, just all we have to do is keep trying over and over and over again. So it's kind of cool. You don't have to like check for errors and throw away your connection object and start a new one. It just will simply work when the failover has finished. But you have to add the retry logic to try over and over again. Otherwise, it will encounter that first intermittent failure and just stop trying, and that's not necessarily a good thing. Also, be careful if you're offloading reporting or long-running queries to your secondary replicas and at the same time making schema changes to your primary, because the secondary replicas can actually block the schema change from applying. And the scenario being, in this case, I had replica 1 and replica 2 were synchronous commit partners. And so in order for a query to finish running and successfully on my primary replica, it had to be hardened into the log of the secondary and communicated back. Well, on the secondary replica, if I'm running a select statement against a table that I'm also trying to alter the structure of, that hardening into the log actually will not finish until it's actually able to do that. And so the select statement will actually block the alter statement on the secondary, which then comes back to your primary and blocks it there as well. And I have a demo of that on my blog as well if you're looking for more information or to be able to reproduce it and see how that happens. So just be aware of that. If you're in an application that has a lot of schema changes that happen to it throughout the course of a workday, then you may not want to offload long-running queries to your secondaries then. Or you may want to just have your schema changes happening off hours and avoid the problem that way. Another set of recommendations here, this is just kind of running through the steps again. The first thing you do is you set up your Windows cluster. Again, I recommend Server 2012 R2 or newer once that's released because of all the enhancements that have come out that make clustering that much better. But if you're on Server 2008 or 2008 R2, don't forget to install the hotfix there that allows you to set up your node voting. And test. Make sure that this is rock solid, because again, it's your foundation that your availability group is sitting on. Once your Windows Server cluster is installed and configured and tested and it's rock solid, then go ahead and install SQL Server 2012 Enterprise Edition or above on each of your replicas. And don't forget to enable that always-on availability groups feature. It's a checkbox in Server Configuration Manager, or do it through PowerShell. Once you've done that, then go ahead and set up your databases on what you want to become your primary replica, and then you'll create your availability group and synchronize those databases across to the other replicas. As far as limitations are concerned, in SQL 2012, you can have 5 total replicas, including your primary. 2 of those are allowed to be automatic failover partners. Up to 3 of them can be synchronous commit. And in SQL 2014, they've upped the maximum to 9 total replicas. Again, 2 automatic failover and 3 synchronous commit. And now you can also have a replica in Azure. And Azure can kind of be your disaster recovery site, which is pretty cool. Finally, when you're creating logins, don't forget to create them with the same SID on all of your servers. So when you do failover, you don't have to remap your database, or sorry, your instance logins to your database users. If the SIDs are the same on all your servers for the login, it will automatically map correctly when a failover occurs. Also, you could use partially contained databases for your logins. That's another way around that as well. Don't forget to create your endpoints. That's how you replicate and to grant permissions to those endpoints. Don't forget to create your listener name and your read-only routes, because that's how you offload your workloads nicely, or how you do the automatic failovers. And that's pretty much it. For references, feel free to go to my blog, www.sqldiablo.com/go/alwayson. And that's where I have a nice collection of links and resources for you. And I'll also have the slide deck and demos up there here shortly. And you can also go to sqldiablo.com/go/deprecated in 2012 for a full list of deprecated features in 2012, including database mirroring. That's when they deprecated that feature. With that, any questions?
I have quite a list of questions, Adam.
Oh boy.
Thank you for the good presentation. Now, one of the questions has to do with the supportability of always-on availability groups with MSDTC distributed transactions.
Right. As far as I understand, distributed transactions are not supported by availability groups, unfortunately. And I don't know that that's going to change. But at this point in time, as far as I understand it, they're not currently supported.
With always-on availability groups, how do I handle things like SQL agent jobs, link servers, and SSIS packages stored in MSDB? I am assuming they would not be in sync in the event of a failover.
That's absolutely right, and essentially that's one part of it that's manual. Is you'll have to synchronize those together. As I mentioned, Jonathan Cahias from SQL Skills has a nice script that he made just for that purpose. That essentially looks at your different replicas and will compare them to one another. And in anything that's out of sync, it generates kind of a change script for. So you can just go to your other replica, run that script, and it brings it into sync. It's pretty good from my understanding. The packages, it may be a little bit more manual to keep the packages in sync. But as far as jobs and logins and all of that kind of thing, it does a nice job of doing that. And if you want, you could probably even schedule that as a job to run every so often to keep them in sync. But really, once you're in sync initially, I would just do a little bit of change control. And anytime we're rolling out a change that is an instance level object, just know that you have to do that to all three of, or however many replicas you have simultaneously to keep them in sync.
Do any reindex or update stats get replicated to the secondary?
They absolutely do. And when they're replicated, it's replicating the transaction. So it's not replicating the command, it's replicating the transaction. So if we do an index update, like a rebuild index, that is 10 gigabytes in size, we're going to send all 10 gigabytes of that transactional data across our replication mechanism. So if it's going to our DR site over a T1 or something even less, it's going to be sending that 10 gigabytes over that connection. And that's definitely something that is a pain point, and it has been a pain point with database mirroring, and it stays a pain point with availability groups as well, where you just have to manage that appropriately.
Is the connection string application intent equals read only used in the availability group or the listener, or where?
That's used by the application that would be connecting to your database. So your third-party application that's connecting to your database is where that would be at. So if I have some in-house application I've written that has a connection to my database, that's where I would put it, is in my application's probably configuration file. And that application intent equals read only is then basically where what the purpose is it's that application is telling SQL Server that when I connect and I use the listener name, that means I'm going to go to the primary replica. Anytime I have the listener name in my connection string, I'm going to the primary. But then defining application intent equals read only is telling the primary replica, if you have routing information to offload me elsewhere, go ahead and do that. And then at that point, the connection switches over to wherever you get offloaded, and you start talking directly to that other server. So again, the connection string and that keyword, those are in the configuration of an application that talks to your database. Those aren't really SQL things that happen with the availability group. It's how you talk to the availability group. I hope that makes sense.
Okay. Does replication, or does I think it means always on availability, require the full recovery model?
It does. It requires full recovery, and it requires an initialized log chain. So you have to have done a full backup at least once of the database.
Since you only have votes on Replica 1 and Replica 2, should you not have disk or file share witness to make it an odd number of votes for the quorum to work properly?
That's a fantastic question. I skipped that for purposes of time, but you're absolutely right. In this case, I have a file share witness because I don't want to have a SAN that I'm reliant on. But I could just as easily have a cluster disk that was my kind of tiebreaker for my quorum. And so my quorum mode is essentially node and file share majority is the quorum mode that I'm using here, to where I have two nodes with votes, and then the tiebreaker vote is my file share.
Do the transactions on the two replicas run synchronously or asynchronously?
It depends on how you configure it. So in this case, I have one of them is a synchronous commit and the other one is asynchronous commit, which would mean if I run a transaction on my primary server, it will run there first. If there's an error that happens, it will just immediately stop and error out. If there are no errors and it's ready to commit the transaction locally on my primary replica, it then sends the transaction to any synchronous replicas. Those synchronous replicas will then run the transaction, and that can happen in parallel at that point, and and basically to write them into the log. And once that is finished and they've been acknowledged back by all synchronous replicas, then the transaction is committed by the primary. In addition to that, once the last thing that the primary will do before it waits for those acknowledgments back is to queue up the transaction to send it to any asynchronous replicas, which happens kind of again asynchronously. So it kind of happens when it happens. Generally it stays pretty quickly in sync if you have a fast reliable connection, but so the order of operations is run the transaction locally, make sure it didn't fail, then send it to all your synchronous commit partners, and then once you've sent it to all your synchronous commit partners, also queue it up locally for your asynchronous commit partners, receive back the acknowledgments that it succeeded on your synchronous commit partners, and then commit locally. So that's kind of the order of operations there.
This has to do with the automatic backups. And it says if you have scripted the backup, say, using the Ola Holmgren scripts, is this not considered automatic?
I believe that Ola's scripts actually do honor these settings. In recent versions, he's actually brought that into it, so it will look at these settings for you. But I would check his documentation for more information around that and how it is interpreting those. But my understanding is that his scripts actually do listen to those settings. But if it were something like a roll your own solution that you made, you would have to query the DMVs to get that information, or just not care about it or honor it.
How do you force the DNS cache flush on the previously connected machine when the DNS change occurs? Or is this solved by having a very short TTL?
It would be a combination of having a short TTL, so that way you would basically be looking to DNS for updates quicker, at a shorter interval. But also your multi-subnet failover equals true connection string will help with this too. And so when it does have a problem connecting to your listener name, multi-subnet failover equals true should make it detect the new primary faster and connect to that regardless of DNS updating in a timely manner. So the two of them will help together. I would rely more upon multi-subnet failover equals true than necessarily setting your TTL to be a smaller value.
Is the availability group technology essentially inheriting some features of database mirroring?
It's even more than that. It's essentially taking database mirroring and extending it. So it's inheriting from database mirroring and growing it to then be a group of databases to also be closer integrated with a cluster and not need a witness server. So the code base is essentially the same code base as database mirroring, just kind of grown and stretched a bit. So it's, yes, I guess would be the short answer to that question.
I describe it as mirroring on steroids.
Exactly, exactly.
Does Microsoft provide any online sandbox environment to play with and configure availability group topology?
That's a really good question. I think they had some online labs when they released SQL 2012, but I don't know if those are still available, and I don't know where they'd be. I can look into that, and if I find them, I'll put them up on my blog on that Always On Resources page, the first link you see on my screen right now.
With SQL 2008, before we used Windows failover clustering, we experienced more downtime than with our current VMs, largely due to the complexity of Windows failover clustering. Should I be concerned about the increased complexity of the availability group to potentially cause more outages? You mentioned the complexity of quorum configuration. Would you talk to this in more detail? How does patching work? That's about 5 questions.
Right. I would say, let me give a short answer and then a short, long answer. So the short answer is I would be concerned about this, and you're asking the right questions. There are a lot of complexities to this solution, and you need to make sure that you've thoroughly tested and vetted it in a like a dev or test scenario, especially with a workload and a data load that are similar to what you have in production, because it is so critical, especially if you're protecting a mission critical system with this. At the same time, the short long answer is I would recommend emailing me and asking your questions again, and I can give you perhaps a more detailed answer to some of your other ones, especially around the complexity of the quorum and that sort of thing. But for the sake of time, I'm not going to really get into that right now.
A question from slide Always On feature comparison. It said you have to pay for other instances, secondary and witness, if using them to read. Can we read from witness? Ideally, witness on Express Edition, which is free, is enough.
Yes, you're exactly right, and you don't have to. Yeah, I mean, you don't have to pay for those instances unless you do run production workload on them. So if your witness is just being a witness and it's not hosting any production databases, you're exactly right. That can happen on Express Edition, and that can be free, regardless of edition. Now, the moment you put a production database on there and you're using it for workload, that's when you have to start licensing it.
Okay, there's a couple of questions about the recording. The recording will be posted, if all goes well, by the end of today or first thing tomorrow. It will be in 2 parts because I lost my connection and had to start the recording again. And that's going to be available. It'll be on the DBA website, dba at dba.sqlpass.org, and it will be there. Adam, if you want to send me your scripts and your slides, I will post them as well.
Yep, I can do that.
How to check the current read-only routing setup on an always-on server?
Oh, that's a great question too. I'm sure there's a DMV that will tell you that. I don't have that handy. I would recommend emailing me as a follow-up, and I'll look into that for you.
And I will send you the questions log, so you will have that as well.
Yep, that might be a good blog topic. I might blog about that.
Okay, if you can only take a normal full backup from the primary replica, when would it be appropriate to choose prefer secondary?
That will, prefer secondary is kind of worded that way on purpose. So it will prefer the secondary when it's allowed to run from a secondary. So if you prefer secondary, full backups will still run on the primary because that's the only place they can run. And then what you're really telling it is to prefer running your T-log backups from your secondary replicas.
A comment I also, not my comment, it's from one of the audience. I also highly recommend adding logic to your SQL agent jobs to check whether they are running on the node hosting the primary replica. If yes, then run. If no, don't run.
Yep, that's a great point as well. Yeah, any kind of automated tasks that you have that are going to be modifying data, I would add that check-in. And like I said, there's a DMV that you can access that tells you that information on whether you're currently on the primary or not. Also, whether you're currently kind of quote-unquote allowed to run a backup or not. Those are all available through system DMVs.
Okay, does the connection string have to have application intent equals read only, or will the availability group know if a query is select only and route it to a secondary?
All right, I'm going to treat that as two questions. So the first question is no, because you might want to run a read-write query, so you would just leave off that application intent keyword, and you're going to get, no matter what, you'll get sent to the primary replica, and you'll stay there because you didn't tell it, you didn't give enough information to route you otherwise. The second half of the question is, will you be routed, is it smart enough to know if you're running a select statement to route you elsewhere? And the answer is no. That's what that application intent equals read only is for. So that's that's basically you telling SQL, I intend to run only read-only queries, go ahead and route me elsewhere. And if you don't tell it that through your connection string, then it has no way of knowing that and will not route you. So you'll stay on the primary then.
And a final comment, you might want to mention using a VMware workstation on a PC with 8 GB RAM works well for testing the Windows Server Foundation cluster and the availability groups.
That's very true, or Hyper-V. That's actually what I hosted my demos out of today, is Hyper-V on Windows 8.1. So that's a great way to set up a lab, and that's a whole other topic I could talk more than an hour about. But for sure, that's a great way to test this out as well.
Thank you very much, Adam. It was quite an interesting presentation, and well done despite the assorted glitches that you encountered. And I'll be looking forward to having you speak for us another time. I have one last thing to do, and that is to announce today's raffle winner. And I'm going to murder this name, Sinisa Vojvodik, who's from Deloitte, Canada. And the headquarters will be in touch with you, and we'll see that you get your prize. And it's now we're half hour over, more than half hour over, but nobody is waiting for this site, so I don't mind if we've gone over, but it is time. Some of you heard the cat that was up here yelling for a minute, and because I didn't have the door closed, and it's time for me to go and feed the cat, and we'll see you all in a couple of weeks for our next meeting. Thank you for coming, and remember, I'm looking for a speaker for May.
Thanks, Sharon. It's been fun.
Thanks.